It is entirely plausible that you are living inside a black hole right now, and you might not even be conscious of it. This journey explores a theory as strange as it is compelling. The idea that our entire cosmos could be contained within one of these cosmic behemoths. Evidence from the James Webb Space Telescope is providing new clues, and its revelations could permanently alter how we perceive reality. The field of cosmology, which examines the universe's origin and evolution, has equipped us with the means to better comprehend our position in this immense cosmic theater. Yet, as our exploration into these theories deepens, we encounter profoundly unsettling questions. Is it possible that the reality you perceive is nothing more than the interior of a gargantuan black hole? While this proposition may sound preposterous at first, it is firmly anchored in scientific principles that defy our conventional understanding of space and time. Black holes are enigmatic celestial bodies, defined as regions of space with a gravitational pull so immense that even light cannot escape. But what is their connection to the universe you inhabit? Picture a colossal vortex in space that inexorably swallows everything that draws near, absorbing it into an endless cycle. If our universe is such an entity, then the very space and time you experience might just be an illusion, sculpted by the overwhelming gravity that envelops us. This concept invites some truly profound contemplation. Should our universe be a black hole, what could possibly exist beyond its event horizon, that is, beyond its vast sphere of influence? Certain theories propose that everything you know is merely one part of a more intricate system, where countless universes are nested together. Such a reality would carry staggering implications for our understanding of life itself. The questions continue to mount. Could you be a resident of a cosmos that operates under a completely different set of physical laws that are still unknown to us? The notion of our cosmic home being a black hole unveils numerous possibilities about the state and future of the universe. If you entertain the idea that every black hole could potentially birth a new universe, it would fundamentally reshape your entire perception of creation and existence. As scientific research progresses, we see that cosmology is in a constant state of flux. Technological marvels like the James Webb Space Telescope offer fresh vantage points of the cosmos, uncovering secrets that were once confined to the realm of imagination. However, each new discovery simultaneously gives rise to even more complex questions about the true nature of black holes and the fundamental structure of the cosmos. The relationship between black holes and the universe is unlikely to be coincidental. In fact, some theorists posit that the properties of black holes are intrinsically interwoven with the formation of galaxies and other large-scale cosmic structures. If this is the case, then every galaxy would be akin to a small eddy in a cosmic river, all subject to the immense gravitational pull of the whole system. Your very experience of time might also be transformed by accepting this theory. Inside a black hole, time functions in a peculiar way, suggesting that our perception of its linear flow could simply be a consequence of the gravity that surrounds us. This opens the door to the fascinating possibility that time is not a straight line but a cyclical phenomenon, entwined in a vast network of universes and black holes. Contemplating these theories forces you to question the very fabric of existence. Are we truly isolated in this immense cosmos, or are we an integral component of something far grander and more mysterious? The idea that our universe is a black hole strongly suggests the potential for other interconnected realities, each with its own unique physical laws and modes of being. In every corner of the world, scientists persist in their quest for answers. The hypothesis that the universe is a black hole is not merely an intriguing thought experiment. It demands that we re-examine everything we believe about life, death, and the cycles of creation. This journey into the unknown reminds us that every unanswered question presents a new opportunity to learn more about ourselves and the cosmos we call home. This field of study, known as black hole cosmology, invites you to look not just outward toward the stars, but also inward, to question your own existence and your place in the universe. It challenges you with a mind-bending question. What if everything you know, from the stars in the night sky to the most remote galaxies, is all enclosed within one giant black hole? While it may seem outlandish, this theory provides a new framework for understanding our observable universe. This perspective also offers a radical alternative to the Big Bang, suggesting that it was not an explosion from a single point, but rather the collapse of a four-dimensional star into the black hole that is our universe. Such an idea completely reframes our concepts of a cosmic beginning and end. Ultimately, this line of inquiry leads to the most fundamental questions of all. Are you truly alone in the universe? And do countless other universes exist inside countless other black holes? The concept of nested universes, much like a set of Russian Matryoshka dolls, proposes that we exist within a landscape of hidden realities, each undergoing its own cycle of expansion and collapse. It is a truly captivating notion to consider that you might be part of an immense cosmic tapestry that interweaves countless different realities. This idea, known as black hole cosmology, is evolving from abstract speculation into a field with emerging scientific support. Recent observations have uncovered specific patterns in both the arrangement of galaxies and the cosmic microwave background radiation, the lingering glow from the Big Bang, which could point to the underlying structure of a black hole. Could our perception of the cosmos be merely a reflection of its internal mechanics? Every black hole represents a profound enigma, and by studying them, you may uncover vital clues about our own existence. In this view, each black hole could serve as a portal to another universe, a reality that remains beyond our sight and full comprehension. Imagine plunging past the event horizon to find a completely new cosmos, brimming with possibilities that exceed anything you could ever conceive. This theory that our own universe is a black hole introduces compelling questions about life and intelligence. If advanced societies thrive inside these cosmic structures, how would they ever make contact with the outside world? Or could they engineer technology to breach their own event horizons? As you delve into black hole cosmology, you are compelled to reconsider fundamental concepts like time and gravity. If our universe is indeed a black hole, time might function in ways previously unimagined. Perhaps time itself is an illusion, a product of the immense gravity that contains us. This framework is also deeply connected to the quest for a unified theory of physics, suggesting that gravity could be the master force that unites all cosmic events. In contemporary cosmology, the investigation of black holes is gaining significant momentum, largely thanks to instruments like the James Webb Space Telescope. We are now able to perceive details that were once entirely out of reach, and observations of dark matter and the cosmic microwave background are providing hints about the universe's ultimate structure. However, this theory remains contentious, with some scientists expressing skepticism due to a lack of definitive empirical evidence, a healthy debate that fuels scientific progress. If compelling proof for this theory emerges, you would have to wonder if we'll be forced to rewrite cosmology textbooks entirely. While exploring black hole cosmology, it is crucial that you maintain an open mind, as each new finding has the potential to offer a radically different perspective on the cosmos and our role within it. The search for answers challenges everything you think you know, and serves as a reminder that the universe is teeming with unsolved mysteries. The idea that our universe is a black hole is not just a scientific puzzle. It connects with you on a philosophical level, underscoring that our curiosity will always outpace our knowledge, and that this very pursuit of understanding is what defines our place in the cosmos. The exploration of the universe has entered a thrilling new era with the deployment of the James Webb Space Telescope. This instrument was engineered not just to give you an unprecedented view of space, but to rekindle our fascination with the deepest questions about the cosmos, with black holes taking center stage. So, what specific part does this advanced telescope play in unraveling these cosmic enigmas? From its first moments in operation, the James Webb Space Telescope has served as our portal into the far reaches of space and time. Its capacity to detect infrared light allows scientists to peer further into the past than ever before, giving you what amounts to a new set of eyes to penetrate the cosmic darkness and expose secrets that have been veiled for billions of years. Among its most captivating discoveries are galaxies that seem to be in the process of forming supermassive black holes at their centers. These entities are truly gargantuan, weighing millions or even billions of times more than our Sun. By studying these distant formations, the Webb telescope enables you to witness how these massive objects evolve and shape their host galaxies, suggesting they may be crucial architects of cosmic structure rather than mere agents of destruction. Moreover, the James Webb Space Telescope has delivered fresh data on the radiation that black holes emit, forcing you to reevaluate established theories. The behavior of matter spiraling into a black hole is a field of intense study, as the tremendous energy it releases can influence the entire galactic environment, raising questions about how such cosmic events might even affect the development of our own planet. The telescope's ability to analyze the universe across multiple wavelengths has also led to a remarkable finding: the presence of complex molecules, the essential building blocks of life, in the vicinity of black holes. This discovery raises a profound question for you to consider. Is it possible that the chaotic environments around black holes could somehow be responsible for creating the conditions necessary for life to arise elsewhere in the universe? It's vital to recognize that the James Webb Space Telescope isn't just peering into the distant past. It is also profoundly enhancing our comprehension of the present universe. As we document more and more black holes and their host galaxies, we're beginning to discern emerging patterns that could unlock the secrets of fundamental physics. If black holes are truly the engines driving galactic evolution, it would completely reshape our understanding of cosmology, an idea that is rapidly moving from a fringe theory to a plausible reality with the Webb telescope's accumulating data. This continuous flow of new information makes the concept that our universe is governed by these mysterious entities increasingly conceivable. The investigation into how black holes shape the very structure of the cosmos is a swiftly expanding field of research, and the James Webb Space Telescope serves as our most powerful instrument for this exploration. You might even be living in a reality fundamentally directed by their immense influence. Naturally, new data gives rise to new questions, such as the potential connection between dark matter and black holes. Is it possible that these two cosmic mysteries are somehow linked? The quest for answers to these inquiries could lead us toward an entirely new understanding of how the universe operates as a whole, providing a more complete picture of the forces at play. The fascination surrounding black holes has intensified dramatically, thanks to the Webb telescope, and the scientific community is buzzing with unprecedented excitement. Each new finding brings us a step closer to solving the cosmic puzzle that has long eluded us. The very possibility that these objects hold the key to the universe's origin and structure compels you to reconsider everything we once thought we knew for certain. In essence, the James Webb Space Telescope has initiated a revolutionary era in cosmological discovery. By allowing us to observe and understand black holes with greater clarity, it provides you with an updated perspective on our place within the cosmos. The intricate connection between these cosmic titans and the universe's architecture is a narrative that is still unfolding with every new observation. As our exploration continues, you should remember that each answer we uncover only leads to more profound questions. This grand adventure of discovery is truly endless, and the James Webb Space Telescope marks just the beginning of a journey that promises to take us to the darkest and most thrilling corners of existence. What other secrets will the cosmos reveal to us in the years to come? To better comprehend this phenomenon, it's essential to visualize the dance of galaxies as they move through the vast ocean of space. Picture a grand ballroom where each galaxy is a dancer with its own unique style. What is remarkable is that a majority of them, despite their individuality, adhere to a specific pattern of movement. This tendency for most galaxies to rotate in the same direction presents you with an intriguing cosmic puzzle. As astronomers study these spinning galaxies more closely, they're realizing the rotation is not merely a curiosity, but has significant implications for our understanding of dark matter and cosmic structure. This mysterious, invisible component appears to be critical in how galaxies form and spin. A captivating theory proposes that this behavior might be explained if our universe exists inside a black hole, with galactic rotation being a reflection of its internal dynamics. This line of inquiry deepens, raising the question of how galactic rotation is connected to the formation of structures across the universe. The answer could be linked to gravitational collapse and a principle known as the conservation of angular momentum. As a cloud of gas and dust contracts under its own gravity to form a galaxy, its rotation naturally begins and then intensifies, suggesting the spin we observe is a direct result of its creation. Yet, not all galaxies conform to this standard. Some rotate in the opposite direction, creating even more questions about the forces at play. What factors could cause this reverse spin? One strong possibility is that interactions between galaxies, such as collisions or mergers, are responsible for these variations. Imagine two dancers colliding on the floor. Their encounter would inevitably change the way each one moves. As scientists analyze vast amounts of observational data, galactic rotation reveals itself as a captivating puzzle. The speeds at which galaxies turn and their alignment with one another may be signs of something far more fundamental. It's possible you are only observing the surface of a complex phenomenon that is a direct reflection of the physical laws governing our entire universe. For decades, the way galaxies spin has intrigued astronomers, and their discoveries have raised some truly fascinating questions about the universe. Why is it that 2/3 of the galaxies we observe rotate in a clockwise direction? This finding is more than just surprising. It challenges our fundamental ideas about randomness in the cosmos and compels us to ask what this means for our understanding of the universe's structure and dynamics. First, it's crucial for you to understand that galaxies are not just chaotic collections of stars drifting through the void. They are highly complex systems, governed by gravitational forces that dictate how they move and organize themselves. When we observe their rotation, we are witnessing these forces in action over immense spans of time. However, the fact that a specific direction of spin is so prevalent raises a key question. Is there some hidden pattern behind this phenomenon? If you picture a whirlpool, you can visualize how eddies tend to swirl in a single direction. On a cosmic scale, galaxies appear to behave in a similar fashion.
Some scientists propose this could be related to angular momentum, which is a physical property describing an object's rotation. Yet this doesn't entirely explain the observed imbalance. Gravity is a central player in this cosmic story, as the forces between stars, gas, and dark matter are decisive as galaxies form and evolve. But this leads to another intriguing possibility. Could these same factors be connected to the theory that our universe itself might be a black hole? The idea that we might be living inside a black hole fundamentally changes how we would interpret these galactic rotations. Dark matter, which constitutes the majority of the universe's mass, could be a key component influencing this spin, much like a whirlpool needs a medium to give it shape and direction. But what if this dark matter plays an even more profound role in the universe's structure, perhaps in its very connection to black holes? This brings us to another fascinating question about randomness in the cosmos.
If galaxies predominantly rotate in one direction, it suggests the existence of underlying laws that we have not yet fully comprehended. Furthermore, this study prompts us to consider the possibility of nested universes, structured like Russian Matryoshka dolls. If our universe is inside a black hole, then it's conceivable that every black hole could be a gateway to another universe, each with its own distinct laws and patterns, which only deepens the complexity of cosmology. As scientists delve into these mysteries, they are increasingly interested in how galactic rotations might offer clues about the universe's true structure. What if the way galaxies spin is intrinsically linked to processes that occur exclusively inside a black hole? Perhaps what we observe in the cosmos is simply a reflection of events unfolding in deeper, more enigmatic dimensions, suggesting that the dynamics of galaxies could be an echo of the intense gravity at work. This idea suggests that, at a more fundamental level, galactic rotation may be connected to the very principles of gravity and relativity. If we could fully understand this rotation, would we then be able to better comprehend the nature of the universe as a whole? The search for answers is an exciting journey that leads us to explore not only our place in the cosmos, but also the very fabric of reality. Meanwhile, the James Webb Space Telescope continues to provide crucial information, reigniting interest in this field by allowing scientists to see details that were previously invisible. Ultimately, the rotation of galaxies reminds us of how little we truly know about the cosmos. Every answer we find seems to give rise to new questions, and each discovery takes us further on our quest for truth. In this vast and mysterious universe, the spin of galaxies is just one thread in the enormous tapestry of our existence. A thread that invites us to keep exploring, keep asking questions, and above all, keep marveling at the grandeur of the unknown. Are you prepared to venture further into the unknown? What if you could peer through a cosmic vantage point that revealed not only our own universe, but also other realities existing far beyond our current comprehension? The concept of nested universes, much like a set of Russian Matryoshka dolls, presents a truly captivating idea to consider. The possibility that our own cosmos is contained within an even greater one, a notion with profound implications. Within the field of cosmology, this idea of nested realities challenges our fundamental understanding of space and time. Could it be that everything you perceive, from the most remote stars to the closest galactic clusters, is merely a small component of a vastly larger cosmic structure? Picture our universe as a single bubble floating in an endless ocean of similar bubbles, each governed by its own distinct physical laws and possessing unique properties, forcing us to redefine what we consider reality. Every time you gaze at the night sky and marvel at the stars, you are faced with the sheer immensity of the cosmos. But what if that perceived vastness is just a tiny fraction of a much grander existence? This possibility that our universe is part of a broader reality compels us to question our own place within it. Are we the sole occupants of our cosmic bubble, or are there other bubbles with beings who are asking these very same questions? This concept of nested universes also opens up fascinating questions about how these different realities might interact. Could there be points where these worlds intersect, or even pathways that would permit travel from one universe to the next? While physics indicates that the laws governing our cosmos are specific, there is no guarantee they would hold true elsewhere. Envisioning a reality where fundamental physical constants are different is a thought that is simultaneously disorienting and deeply exciting. This is not merely a philosophical exercise. The idea is rooted in contemporary physical theories. String theory, for instance, postulates the existence of extra dimensions that could harbor other universes entirely. If our universe occupies one such dimension, it begs the question of what other dimensions might exist and just how many parallel realities could be unfolding alongside our own at this very moment. As you contemplate these nested universes, you also confront the idea that matter and energy could behave in profoundly strange ways. What might occur in a universe where gravity is significantly weaker, or where the speed of light is not the ultimate limit? Such questions lead us into completely uncharted territory, where each potential answer only serves to generate a host of new inquiries. The implications are staggering, especially when considering that some theories propose our universe exists within a black hole, potentially transforming them from cosmic graveyards into gateways to alternate realities. The idea of nested universes also forces us to reevaluate the ultimate destiny of our own cosmos. Is it fated to expand forever, or will it one day collapse back upon itself? If a collapse is its end, could that event give rise to a new universe, initiating another cycle of cosmic existence? This vision of a dynamic, ever-changing multiverse suggests that life, in one form or another, might persist eternally across different planes of reality. Our innate human curiosity is the engine that drives us to seek answers. Yet, it also leaves us humbled by the sheer scale of the cosmos. How many universes might there be beyond what we can observe? Are they hospitable to life? Do they resemble our own, or are they fundamentally different? Each question born from this concept is an invitation to reflect on our own existence and our role in the grand cosmic tapestry. Ultimately, the theory of nested universes provides a powerful new lens through which to view the cosmos. It serves as a reminder that, while our comprehension is finite, our capacity for questioning is limitless, inspiring us to continue exploring what might lie just beyond the next scientific horizon. The search for answers may well guide us to corners of reality we have never even dreamed of investigating. The advancement of science may bring us closer to understanding not just our own universe, but the magnificent array of realities that could coexist with ours. So, the next time you look up at the star-filled sky, allow yourself to imagine that you are not just seeing our cosmos, but gazing into a multiverse, teeming with undiscovered mysteries. Every point of light could be an entrance to another world, a sign that our exploration of reality has only just begun. Will you dare to conceive of what lies beyond? What exactly is an event horizon? For many, the term conjures an image of a boundary where the established laws of physics appear to fail. In essence, the event horizon is an invisible demarcation line that envelops a black hole, Once anything crosses this threshold, its return becomes impossible. But what makes this concept so compelling, and what significance does it hold for us and the universe we inhabit? To better understand this, picture yourself standing on the bank of a powerful river that flows toward a massive waterfall. The event horizon is analogous to the precise line in the water where the current becomes too swift to escape. If you were to cross that line, the river's force would inevitably pull you over the edge. In much the same way, a black hole's immense gravity seizes anything that ventures too close, making this analogy a useful way to visualize how this cosmic boundary functions. Our curiosity naturally pushes us to ask what lies on the other side of this horizon, and whether it is possible to get even a glimpse beyond this point of no return. Scientists have long theorized about this, with some proposing that the laws of physics as we know them simply cease to apply inside a black hole. Could there be an entirely new universe contained within? At the core of a black hole lies the singularity, a point of infinite density. But what does that truly mean for reality itself? To grasp the concept of a singularity, imagine taking all the matter in a massive balloon and compressing it relentlessly. As you squeeze it smaller and smaller, its contents become increasingly dense. If you could continue this process indefinitely, you would, theoretically, concentrate all of its substance into a single, infinitesimal point with no volume, which helps to illustrate the mind-bending nature of a singularity. While this offers a way to comprehend what occurs within a singularity, the reality beyond the event horizon remains an enigma. Certain theorists speculate about a possible link between various universes, suggesting a black hole could serve as a conduit to another location in space. This provocative idea raises the question, could every black hole we observe actually be a gateway to a different cosmos, opening up a universe of possibilities about the very fabric of reality? The event horizon also presents a fascinating proposition. What if the observable universe is, in a way, one immense black hole? Pondering this concept compels us to reevaluate our perception of the world around us. If our cosmos is indeed a black hole, could we ever glimpse what exists past its own event horizon? Such a notion carries profound implications, suggesting that the limits of our knowledge are vastly more expansive than we have ever conceived, with other universes potentially connected in ways we have yet to grasp. Time's very direction is intricately tied to the event horizon. As you draw nearer to a black hole, time itself seems to decelerate. But what causes this phenomenon? Is it possible that time is merely an illusion shaped by the black hole's immense gravitational pull? This strange effect might offer clues that help us decipher how time operates at its most fundamental level. The study of the event horizon brings forth even more profound inquiries. If you were to traverse this boundary, could you ever transmit information back? What becomes of the data that vanishes once it crosses this threshold? The renowned information paradox challenges our understanding of what information truly is, and whether it can be permanently lost or must somehow be conserved. As you contemplate these mind-bending ideas, it's crucial to acknowledge that science is still far from having complete answers. The event horizon of a black hole symbolizes just one of the countless mysteries the universe holds. Yet, every new hypothesis and breakthrough inches us closer to unlocking the secrets concealed within the deepest reaches of space. Black holes and their event horizons serve as an invitation to challenge what you believe about existence. They encourage you to peer beyond conventional perceptions and entertain the possibility that life as you understand it is but a minor component of a far grander design. In this light, cosmology becomes more than just a study of the universe.
it evolves into an exploration of the most fundamental questions about our own being.
Have you ever considered that every black hole dotting the night sky might not be a mere void, but rather a portal to an entirely new universe? This concept envisions a reality structured like nested Russian Matryoshka dolls, where one universe is contained within another. It suggests we could be inhabiting a kind of cosmic Matryoshka, a notion supported by theories that push the boundaries of our current understanding of physics. When you observe a black hole, what you are actually seeing is its boundary, the event horizon. This is the ultimate point of no return, where gravity's grip is so powerful that nothing, not even light, can break free. But what might exist beyond this enigmatic frontier? It is here that theories propose not an end, but a new beginning, an entire world, a complete universe awaiting discovery. Imagine the interior of a black hole as a parallel reality, where the physical laws you take for granted might operate in completely unfamiliar ways. To grasp this, consider how black holes are born from the gravitational collapse of massive stars. What if this very process of collapse also sparks the birth of a new universe? This theory paints black holes not as the tragic finales of stellar life, but as cosmic incubators, generating new dimensions of space, time, and reality. This perspective radically alters our view of the cosmos. If each black hole can harbor a universe, just how many might exist? We could be surrounded by an infinite number of realities, each encapsulated within its own black hole. This in turn provokes questions about our own existence. If our universe is the interior of a black hole, who or what might be observing us from the outside? It's a thought that forces us to see our place in the cosmos in an entirely new light. As you delve deeper into these questions, you encounter ideas that seem to belong in science fiction. Picture a cosmos in a state of eternal expansion, with other universes continuously being born and dying in a ceaseless cycle. Could life thrive in these other realms? Would their inhabitants be aware of their cosmic predicament, just as we are beginning to question our own? This concept of nested universes fundamentally challenges our perception of what is real. To visualize it, you might think of a tree where each black hole is a branch extending toward new possibilities. Just as every branch can sprout new leaves, each black hole might give rise to a new universe, endlessly complicating and enriching the structure of reality. What if you were to imagine every single leaf on a tree as a distinct universe, each with its own unique history and physical laws? Well, this is a poetic thought. The theory that universes might exist inside black holes brings with it significant challenges. The most pressing question is how we could ever manage to observe or communicate with these concealed cosmos. At this juncture, science and philosophy become deeply intertwined, suggesting that the questions we pose might be just as meaningful as any answers we could find. Are our limitations purely a matter of our current technological development? Or are there fundamental barriers preventing us from exploring the unknown that lies beyond an event horizon? As you ponder these profound questions, it's hard not to feel a sense of wonder. The sheer possibility that every black hole cradles an entire universe serves as a powerful reminder of how little we genuinely comprehend about the cosmos. It's an invitation to keep an open mind and acknowledge that reality could be vastly more intricate than we currently perceive. We find ourselves at a critical crossroads in our journey to understand the universe. The concept that our own cosmic dwelling might be just one component of a far grander, more elaborate system forces us to reevaluate our deepest beliefs about existence itself and our role within the vast cosmic framework. This leads to the ultimate question. Are you prepared to accept that we might be an infinitesimal part of an immense multiverse? The solutions may be beyond our present grasp, but the one certainty is that the possibilities are boundless. From the mysteries of black holes to the speculation of hidden universes, each new discovery brings us another step closer to solving the great puzzles of the cosmos. It fuels the hope that, perhaps one day, humanity might devise a way to traverse these cosmic boundaries and witness what truly lies beyond. Within the immense stage of the universe, a phenomenon exists that fascinates scientists and dreamers alike, the black hole. But to grasp how these enigmatic celestial objects come into being, you must first explore the incredible process of gravitational collapse. When a star approaches the end of its existence, it undergoes a sequence of changes as dramatic as any epic tale. Picture a star of colossal size, many times more massive than our own sun. As it burns through its nuclear fuel, its power starts to fade, and the once brilliant celestial body begins to weaken. But what occurs when it can no longer generate enough outward pressure to support its own immense mass? This is the moment where gravity assumes its ultimate, decisive role. Gravity is the universal force that draws all matter together, acting like an invisible cosmic tether. For a dying star, however, its own gravitational pull becomes an unstoppable force. Once the outward push from nuclear fusion in the star's core fails to counteract the inward crush of gravity, the star is compelled to collapse in on itself. In a fraction of a second, its core is violently compressed, and this catastrophic clash of forces triggers a spectacular stellar explosion known as a supernova. But what is left behind in the aftermath of this cosmic detonation? If the original star was sufficiently massive, the remnant is a small yet extraordinarily dense core. This object is what becomes a black hole, a region in space-time where gravity is so overwhelmingly powerful that nothing, including light itself, can escape its grasp. Think of it as a cosmic vortex from which there is no return, a point where the gravitational pull becomes absolute. This raises a critical question. How does matter behave within such an extreme environment? Inside the event horizon of a black hole, the laws of physics as you understand them appear to fall apart completely. Particles that once had distinct properties are absorbed into a state of quantum chaos. Space and time become distorted in ways that are difficult to even conceptualize, like trying to navigate a map that constantly reshapes itself before your eyes. As you observe matter being drawn into a black hole, it is superheated to unimaginable temperatures, causing it to emit a tremendous amount of energy. This phenomenon can produce powerful jets of radiation, including what is known as Hawking radiation, which is one of the very few signatures that allow us to detect a black hole's presence. The existence of this radiation was first outlined in the theory proposed by Stephen Hawking, who argued that while black holes are voracious consumers of matter, they can also slowly leak tiny amounts of energy back into space. Gravitational collapse is not merely a captivating astronomical event. It also prompts profound questions about the ultimate destiny of matter. When a star transforms into a black hole, is everything it consumed lost to our universe forever? Or is it possible that this matter could be reborn somewhere else in the cosmos? Certain theories propose that matter plunging into a black hole might be repurposed, potentially emerging in other universes or dimensions, suggesting a grand cosmic recycling system. This cycle of stellar life and death reinforces the idea that even in the most obscure corners of the universe, a perpetual process of creation and destruction is at play.
The formation of a black hole is therefore not just an end, but perhaps a new beginning, with each one potentially serving as a seed for the birth of new stars, or even entirely new universes. This makes you wonder if every black hole could indeed contain a self-contained cosmos. The notion that gravitational collapse could be the start of something entirely new is profoundly compelling. Much like a fallen tree in a forest enriches the soil and allows new life to flourish, a black hole could act as a catalyst for generating entirely new realities. Could it be that at the very core of each black hole there lies an infinite capacity for cosmic renewal? The process of a black hole's creation is ultimately not just about the death of a star, but about the ongoing transformation of the universe itself. Each time a star collapses, it permanently alters the fabric of space-time. Galaxies will continue to spin and stars will continue to shine, yet in the deep quiet of space, black holes remain as the silent guardians of the universe's most profound secrets. So, the next time you gaze up at the night sky, remember that there is so much more happening than what you can see. Every star may be on a path toward its own gravitational collapse, destined to become a black hole that, while invisible, plays an essential part in the cosmic dance of creation.
Within this immense cosmic theater, black holes are the central figures, constantly reminding us that everything in the cycle of existence has its purpose, even what appears to be a final end. This leads us to a captivating thought. Is it possible that inside a black hole, death is not a conclusion, but merely the start of a new chapter? This very question brings us to the astonishing theory of the black hole bounce, a concept that challenges our fundamental understanding of physics and the true nature of reality. In this discussion, we will explore how black holes, those enigmatic cosmic regions with gravity so powerful that nothing can escape, might hold secrets capable of transforming our very understanding of life. Your typical image of a black hole is likely one of an inescapable abyss, a cosmic prison where matter and light are ensnared forever. But what if I were to suggest that some scientists theorize the internal processes of a black hole could actually avert the formation of a singularity, turning what seems like an end into a cyclical process that births entirely new universes? The concept of a cosmic bounce emerges from the challenge of unifying our knowledge of gravity with the principles of quantum physics. On one side, we have Einstein's theory of relativity, which elegantly portrays gravity as the warping of space-time. On the other, quantum mechanics reveals that matter operates in ways that are often bizarre and probabilistic. This fundamental conflict raises a critical question. What truly occurs when a massive star implodes under its own weight to become a black hole? It has been theorized that instead of collapsing to an infinitely dense point where our known laws of physics break down, the process could be arrested by quantum effects, meaning matter isn't destroyed, but rather transformed. So what if the matter and energy pulled into a black hole aren't just consumed, but are instead fundamentally reconfigured and redeployed to create a new cosmos? Consider the analogy of an inflatable ball being squeezed under immense pressure. The moment that pressure is lifted, the ball springs back to its original form and might even expand beyond its initial volume. This comparison helps illustrate how a bounce could function inside a black hole, suggesting the collapse is not a final state, but merely a transitional phase. This isn't just a flight of fancy. Some theoretical physicists are actively constructing mathematical models that support the idea of a bounce as a key feature in the life cycle of black holes. By investigating how matter behaves in such extreme environments, they are unlocking the possibility that every black hole could serve as a portal to another universe. But what would such a reality imply for our knowledge of the Big Bang? If new universes can be generated by black holes, is it conceivable that our own universe is the outcome of such a bounce event?
The proposition that our cosmos might be the progeny of a black hole from another is a fascinating and potent concept, compelling us to reflect on the cyclical nature of everything. This line of reasoning also prompts us to consider the potential eternity of the universe. If each black hole can spark a new cosmos, it suggests the universe may never truly cease to exist, but is instead in a state of constant metamorphosis.
The notion of a universe undergoing perpetual rebirth and evolution fundamentally contests our conventional ideas about time and existence. However, the black hole bounce hypothesis also introduces some perplexing questions. If universes can be born from black holes, what becomes of the laws of physics within these new realms? Would they mirror our own, or could each new universe operate under its own distinct set of rules? This thought leads us to imagine a vast multiverse, teeming with diverse realities, each possessing its own unique properties and potential for life. The idea that the end of one universe could catalyze the beginning of another offers a poetic framework for understanding this cosmic cycle. It encourages us to view existence across the vastness of space not as static, but as a phenomenon in continuous development, rich with limitless possibilities. As we investigate these theories more deeply, it's vital to acknowledge that we are navigating the very frontiers of human knowledge. Science is constantly advancing, and every new discovery brings us closer to comprehending these extreme phenomena. Human curiosity, fueled by these profound and essential questions, is the engine that will ultimately drive us to unravel the secrets of black holes and their deep connection to the universe. When contemplating the bounce within black holes, maintaining an open mind is essential. Who can say how many mysteries remain hidden in the boundless cosmos? The quest for understanding is a timeless journey, and each answer we find only gives rise to new questions, keeping the flame of inquiry that defines our humanity brightly lit. Cosmic inflation stands as one of modern cosmology's most compelling theories. But have you ever considered its link to black holes? To grasp this connection, we first need to understand what cosmic inflation entails. Picture the universe in its earliest moments undergoing a period of exponential growth, as if you were blowing up a balloon at an unbelievable rate. In a fraction of a second, the universe swelled from the size of an atom to cover immense distances, an expansion that helps explain the universe's uniformity and may also hold clues about black holes. The theory that a black hole is not a final destination, but a new origin point, aligns perfectly with the bounce concept. This model proposes that whatever happens inside a black hole could stop a singularity from forming. That point of such intense gravity that physics as we understand it simply stops working. It is truly staggering to consider that instead of being crushed into absolute oblivion, the matter and energy inside a black hole might rebound into new forms that ultimately seed the creation of new universes. Much like a tennis ball striking the ground can cause it to ricochet in new directions, perhaps the material captured by a black hole is transformed and expands into an entirely new reality. What then are the ramifications of this for our perception of the universe? The bounce model for black holes could hold the answers to some of the most profound questions in cosmology. If it's true that every black hole gives birth to a new universe, then the cosmos we inhabit might be just one among an infinite number of others. This line of thought introduces the concept of a multiverse, suggesting that every black hole could serve as a gateway to a separate existence. In this model, you would find a new realm of space and time, potentially governed by entirely different laws of physics. The relationship between cosmic inflation and black holes deepens from there, as theory suggests that if a black hole can birth a new universe, inflation itself might be a repeatable phenomenon. This possibility hints at a potentially limitless cycle of cosmic expansion and contraction, where the collapse of each black hole initiates a fresh era of creation. You can picture it as a perpetual life cycle for the cosmos, one that has no true end. This idea also raises profound questions about time, especially if you consider inflation and the cosmic bounce to be linked. Our perception of time would have to change, as it might not be a linear progression, but a cyclical one, where past, present, and future are tangled in ways we have yet to grasp. One of the most extraordinary implications is that each of these universes, born from a black hole, could harbor its own unique forms of life. If our own existence is the product of such a bounce, imagine the kinds of beings that might populate these alternate realities. Would they bear any resemblance to us, or would they be completely alien? To even consider civilizations that evolved under fundamentally different physical conditions forces you to reconsider the very definition of life itself. Furthermore, this model of cosmic inflation could provide a solution to the puzzle of dark energy, the mysterious force driving the accelerated expansion of our universe. It's conceivable that if black holes are indeed cosmic nurseries, then dark energy might be a residual effect of these bounce events, a kind of afterglow from the creation of new dimensions. The notion that you and I inhabit a universe that is just one part of an infinite cycle is simultaneously daunting and deeply inspiring. The idea that every conclusion within a black hole might actually represent a new genesis opens a universe of possibilities. However, it also underscores how much remains unknown, pointing to facets of existence that are currently far beyond our comprehension. It is crucial to remember that these concepts are still developing theories, and the link between cosmic inflation and black holes is a vibrant field of study engaging scientists globally. With every step forward in our pursuit of knowledge, we may illuminate more about the universe's fundamental nature and our own position within it. As you contemplate the vastness of the cosmos, it's a thrilling thought that your existence could be a single chapter in a grander cycle, where each black hole is a doorway to a new reality. This type of speculation doesn't just stimulate our curiosity, it compels us to challenge our core beliefs about life, time, and the universe itself. The journey to fully grasp cosmic inflation and its ties to black holes has only just begun, with each new answer likely unlocking a host of new questions. This relentless drive for understanding is what makes science so compelling. Ultimately, what we uncover may not only revolutionize our view of the cosmos, but also reshape our perception of ourselves and our role in the immense fabric of reality. This brings us to the concept of Einstein-Rosen bridges, more famously known as wormholes, which transports us to a fascinating intersection of physics and imagination. What if I told you that theoretical pathways exist in the universe that could connect two incredibly distant points, acting like secret passages in a cosmic labyrinth? These bridges might be more than just speculation. They could be gateways to entirely different universes. The idea of a wormhole originates from Albert Einstein's general theory of relativity, which proposed that gravity can bend and warp the very fabric of space and time. This distortion of space-time is what makes them possible. To visualize how this works, picture space-time as a vast, flexible sheet. If you place a heavy bowling ball in its center, the sheet will dip and curve. A marble rolled nearby will then be drawn toward that depression, mimicking how a planet orbits a star. A wormhole takes this a step further. Imagine folding the sheet over on itself and punching a hole through both layers. This creates a tunnel connecting two remote locations, which could, theoretically, allow a traveler to pass between them almost instantaneously. Wouldn't it be astonishing to journey from our galaxy to another in the span of a moment? This is where the practical challenges emerge. The existence of wormholes is far from proven, and scientists are actively debating their potential formation and characteristics. Imagine these Einstein-Rosen bridges are like magical tunnels between two major cities. Instead of enduring a long journey, you could simply step through the tunnel and arrive at your destination in an instant. But what if that tunnel was unstable, staying open for only a fraction of a second before vanishing? This concept also introduces fascinating questions about time itself. Is it possible that traveling through one of these cosmic bridges isn't just a journey through space, but also through time? You could emerge in the distant past or a far-flung future. The possibility that these wormholes could serve as portals to other eras and realities fundamentally challenges our understanding of the universe. However, theoretical physics suggests that for a wormhole to be stable enough for passage, it would require a type of exotic matter we've never observed, something with bizarre properties like negative density. This leads to the crucial question: does this exotic matter actually exist anywhere in our universe? Or is it purely a mathematical construct? The search for it remains one of the great challenges in modern physics. Throughout the years, science fiction has eagerly embraced the concept of wormholes, using them as plot devices in countless books and films. These stories have explored how travelers might use these cosmic shortcuts to rescue worlds, discover ancient civilizations, or escape from impending disasters, firing up our collective imagination. Just how much of this concept is pure speculation, and what portion might have a basis in scientific fact? The answer at this moment remains elusive. The consequences of these wormholes are truly staggering. If their existence were confirmed and we could harness them, it would fundamentally alter our view of the universe. It would transform from a vast, solitary expanse into an interconnected network, making travel across both space and time a conceivable reality. But what would happen to the fundamental laws of physics? Would they hold true as you transition from one universe to the next? The presence of these cosmic bridges also brings up deep questions about the very essence of life. If wormholes link to other universes, it's possible that life exists in those parallel worlds. The notion that we might not be alone across a multitude of universes is a prospect as exhilarating as it is intimidating. Some scientists have put forward the theory that wormholes might serve as an exit for black holes, suggesting that instead of being a final destination, they could be a passage to somewhere else. Are we, as a species, prepared to delve into these cosmic enigmas? Since the dawn of humanity, we have gazed at the heavens, searching for answers about our own place in the cosmos. It's conceivable that wormholes are the very key to unlocking these profound secrets. Investigating Einstein-Rosen bridges compels us to challenge our established knowledge of the universe. It's possible that the cosmos is not merely a collection of stars and planets, but rather an elaborate labyrinth teeming with possibilities. In this view, every black hole could represent a portal to an undiscovered universe, waiting for us to find it. Exploring these ideas not only advances our understanding of space and time, but also forces us to contemplate our own significance in this immense ocean of being. As our search for these mysteries progresses, it's crucial to remember that science is an unending voyage of discovery. Although wormholes and Einstein-Rosen bridges currently exist only in theory, each piece of new research edges us closer to grasping the hidden architecture of the universe. What other wonders, you might ask, does the cosmos have concealed from us? Have you ever thought of black holes as something beyond a simple cosmic event? It's possible that concealed within their enigmatic nature is the secret to how a highly advanced civilization might learn to manipulate the fabric of space and time.
The concept of intelligent beings engineering artificial black holes may seem like something out of science fiction, but what if it's actually achievable? In this boundless universe, where the laws we know might just be malleable, every hypothesis is another rung on the ladder of knowledge.
Fabricating an artificial black hole would be tantamount to opening a gateway to dimensions we can't yet imagine. Could you fathom the possibility of compressing matter so intensely that a new black hole is born? Such a feat would not only test the limits of our comprehension of physics, but could also empower a sophisticated civilization to traverse the cosmos in ways that currently seem impossible. But what would be the motivation for undertaking such a monumental task? A compelling reason could be the pursuit of new frontiers. If a black hole could function as a doorway to different universes or epochs, it would represent an unparalleled asset for any civilization committed to expanding its horizons. How would this, in turn, reshape our entire conception of the universe we inhabit? Furthermore, the creation of artificial black holes would signify an extraordinary command over both energy and matter. Picture the sheer power wielded by a civilization that could bend gravity to its will. This level of mastery could trigger technological leaps that would redefine our way of life entirely. Yet, it must be asked, could this capability also introduce dangers beyond our wildest fears? History has repeatedly shown that powerful technology, if misused, can become profoundly destructive. Certain scientists speculate that developing artificial black holes could be a strategy for an advanced civilization to guarantee its own long-term survival. In a cosmos filled with potential threats, forging a sanctuary in the form of a black hole might be a viable defensive plan. But what if that same civilization, in its act of creation, accidentally unleashed forces it was unable to contain? At that point, the distinction between creation and annihilation becomes perilously thin. On the other hand, the concept of artificial black holes introduces the likelihood of civilizations that have already mastered this technology. It's conceivable that, in some distant corner of the universe, highly evolved beings are already using black holes for transportation or even as power plants. This possibility leads to a fascinating puzzle. If other civilizations are indeed creating black holes, why have we found no trace of their activities? The Fermi paradox, which highlights the stark contrast between the high statistical probability of extraterrestrial intelligence and the complete lack of any evidence for it, gives us pause. Is it possible that these advanced civilizations are fully aware of the risks tied to black holes and have consequently decided to stay concealed? If black holes are indeed passages to other realms, maybe they have chosen not to reveal their secrets to the rest of the cosmos. The idea that a sophisticated civilization could create black holes also forces us to consider the future of our own species. Should we ever attain the required technology, what sort of black holes would we choose to make? Will they become instruments of exploration, or will they be fashioned into weapons of unparalleled, destructive force? The choices we make down the road could carry consequences on a cosmic scale. A black hole engineered by a civilization could possess unique properties. It might be specifically designed to serve as a repository for information, or perhaps even to gather and release energy in a controlled fashion. Imagine a black hole that, rather than consuming everything that draws near, could be harnessed to emit power on demand. Such a breakthrough would fundamentally alter our grasp of both physics and technology. With each step forward in our comprehension of physics and cosmology, a host of new questions surfaces. The very possibility of advanced civilizations creating black holes forces us to reevaluate our position in the grand scheme of the universe. It pushes us to question everything we thought we knew and continue our relentless journey into the unknown. Do we exist in solitude within this immense darkness, or is our reality woven into a cosmic tapestry far more complex than we can grasp? This line of inquiry also brings up crucial questions of ethics and accountability. If we ever achieve the capability to generate black holes, will we possess the maturity to wield such power with caution and foresight? Our own history repeatedly demonstrates that knowledge without a sense of responsibility can have devastating outcomes, forcing us to question if we are truly prepared for the consequences of our own ingenuity. This all culminates in a final contemplation. If black holes are in fact portals to other universes, what would that imply for our entire understanding of life and existence? The mere chance that other civilizations might have already created their own black holes encourages us to dream on a grand scale. But it also serves as a potent reminder to proceed with caution in our relentless quest for knowledge. With every answer we uncover, a new set of questions inevitably arises, ensuring the search for cosmic understanding is a journey without end. The Fermi paradox confronts you with a profound and fascinating question. In a universe so expansive and teeming with possibilities, where is every other advanced civilization? This puzzle has captivated the minds of scientists, philosophers, and curious thinkers for many decades. Imagine the cosmos as a vast ocean filled with islands capable of supporting intelligent life. Despite this, it appears we are navigating these waters entirely on our own. The question is, why? To begin, you must appreciate the sheer scale of the universe. With trillions of stars and even more planets, the statistical odds of life emerging elsewhere seem incredibly high. And yet, even with our most advanced tools and methods, we have failed to detect any unambiguous signals from an extraterrestrial source. This lack of contact forces a rather unsettling thought. What if advanced civilizations are exceedingly uncommon? Time itself could offer one potential solution to this cosmic mystery. While life has thrived on Earth for billions of years, our own technological society is merely a few thousand years old. It is conceivable that most civilizations develop advanced technology only to ultimately bring about their own destruction, which would explain why we have yet to receive any greetings from our neighbors in the galaxy. The lifespan of a civilization might just be a critical and fleeting variable. Another compelling theory suggests that advanced societies might be fundamentally different from anything we can currently conceive. What if they operate with technologies that are completely imperceptible to us? You could entertain the idea that a civilization far beyond our own might exist in a separate dimension or communicate through channels we are not yet equipped to understand. The cosmic silence we perceive could simply be a reflection of our own technological and perceptual limitations. There is also the hypothesis that other civilizations might deliberately choose to remain silent. It's possible they are observing us much like we study animals in their native habitats, perhaps viewing humanity as a developing or even endangered species. They may have collectively decided against interfering in our evolution, preferring to let us learn and progress independently. To them, we might be nothing more than a long-running cosmic experiment. However, some contend that if life were truly prevalent, we should have detected signals from other worlds by now. This raises the possibility that our search for extraterrestrial intelligence is simply focused on the wrong things. Instead of listening for radio waves or looking for optical signals, perhaps our efforts should be directed toward identifying entirely different indicators of life, as the very nature of communication could be far more complex than we assume. Furthermore, the concept known as the Great Filter provides yet another angle on this problem. This theory posits that there is some monumental obstacle to the long-term survival and development of intelligent life.
Perhaps the necessary conditions for a civilization to emerge are incredibly rare, or maybe catastrophic events like nuclear wars and ecological collapse are far more common throughout the cosmos than we would like to believe. In this light, the silence of the universe could be the echo of countless civilizations that did not survive.
It is also vital for you to consider that life as we understand it might not be the only form of intelligent existence. Our entire definition of life is based on our singular experience here on Earth. Consequently, it is entirely possible that other life forms exist which are so profoundly different that we would fail to even recognize them as being alive. They could be so alien that they remain completely beyond our ability to perceive. Ultimately, the Fermi paradox compels us to examine our own capabilities and readiness. Are we truly prepared to comprehend and interact with a civilization far more advanced than our own? If an alien species were to make contact, could we ever hope to establish meaningful communication? The barriers presented by language, culture, and biology might prove to be simply insurmountable. In this context, it is fascinating to consider how our own cultural narratives and expectations shape our search. Stories of mysterious government agents and alien invasions are staples of popular culture, but the reality of a first encounter would likely be far more nuanced and subtle. Perhaps contact with other intelligent beings is beyond our current reach. Or maybe we are just now beginning the process of preparing ourselves for it. The Fermi paradox doesn't just raise questions about life elsewhere in the cosmos. It also encourages us to turn our gaze inward and reflect on what it means to be human in such a vast and enigmatic universe. Every discovery we make about the cosmos simultaneously deepens the understanding of our own existence and our place within it. As we continue to scan the heavens, it is essential that we maintain an open mind and a spirit of boundless curiosity. The answer to this grand cosmic question might be closer than we suspect, or perhaps the real wonder isn't in finding others, but in the ongoing journey to understand ourselves and our unique story within this immense universe. What if the cosmos isn't just an empty expanse, but a system in delicate equilibrium, with conditions perfectly arranged for life to emerge? This puzzle has captivated thinkers for centuries, as the fine-tuning of the universe invites us to ask why the fundamental laws and constants of physics seem so exquisitely calibrated to permit life as we know it. The very concept of a finely tuned universe presents a host of intriguing questions. For instance, what process determined the precise initial conditions of the Big Bang? If a fundamental force like gravity were even slightly more powerful, stars would have developed very differently, and the possibility for life might have been extinguished before it ever began. Consider that if a fundamental value like the electromagnetic constant were even slightly different, the very atoms comprising our reality could become unstable. This raises a profound question. How did all these universal variables achieve such extraordinary precision? To grasp this, you can picture a dart representing the universe's properties being thrown at a target that symbolizes the conditions necessary for life. A perfect bullseye would signify that all cosmic constants have aligned flawlessly to permit existence, but one has to wonder what the odds of such a lucky shot truly are. This incredible coincidence has prompted some cosmologists to propose the existence of countless other universes, each governed by its own unique set of physical laws. If you envision an immense sea of these universes, some would be inhospitable, while others might be perfectly suited for life. Within this framework, our own reality is simply one of the fortunate few where the conditions happened to be just right.
Yet this concept of a multiverse, where each reality has different physical constants, presents a new puzzle. If an infinite number of universes exist, what accounts for the seeming perfection of ours, and what, if anything, makes it special?
When you stop to consider it, the concept of a fine-tuned universe forces a deeper contemplation of life's very nature. The complex and varied life we observe appears to emerge whenever conditions permit. But is this merely a fortunate outcome in a random cosmos? Or does it hint at a grander design beyond our current comprehension? This line of questioning inevitably leads to an examination of our own place in the universe. If the cosmos is so exquisitely calibrated for life, does that imply our existence has a purpose? While some would contend that life possesses an intrinsic meaning, others view it as a simple product of cosmic chance, a debate that brings science and philosophy into a shared search for answers. An even more provocative thought emerges from this. Could humanity, through its very pursuit of understanding, be influencing the conditions of the universe? Imagine if our collective actions and choices could actually alter the fabric of reality itself. This isn't entirely without precedent, as phenomena in quantum mechanics suggest that the act of observation can fundamentally change the outcome of events, raising the question of whether we can truly affect the cosmos on a grander scale.
The Fermi paradox weaves itself into this conversation as well, asking why, in a universe so immense and filled with potential, we have yet to find any signs of other intelligent civilizations. Could it be that life has indeed flourished, but in parallel universes that remain undetectable to us? Alternatively, perhaps their existence, much like our own, hinges on such a specific and improbable set of conditions that intelligent life is an extreme rarity across the cosmos.
Ultimately, the puzzle of the universe's fine-tuning does more than make you ponder cosmic life. It challenges you to consider your own role as an observer of reality. Are we just passive onlookers in this sprawling network of galaxies and stars, or do we play an active part in shaping its destiny? This inquiry transcends science, becoming a reflection on the essence of existence itself. It's a journey fueled by the very human curiosity that compels us to seek answers and find our place within this magnificent and enigmatic cosmos. Now, let's explore an even more captivating idea, that our universe is an artificially engineered black hole, constructed by a far more advanced civilization. This concept opens a gateway to limitless speculation. For a moment, entertain the thought that our reality is not a naturally occurring expanse, but rather a meticulously designed experiment. A sophisticated simulation run by beings whose technology is beyond our wildest imagination. The implications for our understanding of life and existence would be truly profound. To begin, you have to appreciate the sheer scale of this proposition, as it implies a creator behind our reality. What kind of advanced civilization could achieve such a feat? It might be a species so technologically evolved that they can manipulate the fundamental laws of physics, allowing them to construct entire realities from scratch. Much like we design intricate video games, they may have architected our universe, a thought which is simultaneously unsettling and utterly awe-inspiring to consider. So, how might such a phenomenon actually work? We know black holes are defined by their immense power to draw in matter and energy. But what if their singularities are not endpoints, but birthplaces for entirely new universes? In this scenario, every black hole could serve as a portal to a different reality, making our own universe just one of many such experiments. This could even suggest that, at the end of life, we pass through a threshold into another level of existence, a new dimension crafted by these same creators. This concept of an engineered reality forces us to question the nature of life itself. If our universe was designed, does that imply that we are in some sense programmed? Could our choices, our thoughts, and even our deepest feelings be part of a grand script authored by minds far beyond our comprehension? While this idea can be disorienting, it can also provide a strange comfort. The possibility that we are not adrift and alone in the cosmos, but are instead integral parts of something far grander. Venturing deeper into this thought experiment, we must also confront the ethical questions it raises. If it were confirmed that we inhabit an artificial universe, what would that say about our free will? Are we merely players in some cosmic game? And yet, such a revelation wouldn't necessarily strip our existence of its beauty and significance. Even if this is all a simulation, the value of our experiences, our emotions, and our connections with one another remains intact, because even characters in a well-crafted story can live rich and meaningful lives. The concept of artificial universes is also deeply connected to the search for intelligent life, a puzzle highlighted by the Fermi paradox. If other civilizations possess the power to engineer artificial black holes, then why is the cosmos so profoundly silent? It's possible that, much like us, they are completely immersed in their own created realities, unaware of anything beyond them. Alternatively, some may have consciously decided against interfering in our development, choosing instead to observe us from a distance. Certain theories propose that black holes could be cosmic nurseries where entirely new universes are born. When a massive star collapses, it doesn't simply consume matter. It might also function as a portal to a different reality. This idea suggests that on the other side of every black hole, a tremendous burst of matter and energy could ignite the formation of a new cosmos. You can just imagine that the black holes in our own galaxy might be the genesis points for new life and alternate realities, simply waiting for us to find them. Thinking of our universe as an artificial creation also fundamentally challenges our understanding of time and space. If you were living inside a simulation, does that make the passage of time nothing more than a programmed illusion? It could be that our perception of time is simply an architecture built into the simulation to make our reality coherent. Such a realization would completely reshape how you view both our collective past and our shared future. One of the most compelling parts of this theory is the idea that other beings, just like you, are wrestling with the very same existential questions. What if, scattered throughout other universes, there are civilizations pondering if their own existence is the handiwork of some greater intelligence? This potential web of shared inquiry might be a reflection of the sheer complexity of the cosmos and our own small but significant place within it. The notion that we might inhabit an artificial universe could also serve as a powerful catalyst for human creativity and technological progress. If you can envision a cosmos crafted by a more advanced civilization, what does that imply about our own species' potential? By accepting that we may be part of a simulation, we might be driven to push the limits of our own science and engineering, aspiring to one day become the creators of our own realities. Ultimately, contemplating this possibility can instill in us a profound sense of humility. If our reality is indeed a black hole engineered by a superior civilization, it means you are part of an intricate, multi-layered existence that is far beyond our current comprehension. Every new insight you gain about the universe is another small step toward grasping your true position in this grand cosmic design. As you explore these fascinating concepts, it's vital to remain inquisitive and receptive to new ideas. The field of cosmology is in a constant state of flux, where each answer you uncover only leads to more complex questions. You should never cease your exploration, your questioning, and your wonder at the universe's mysteries. because you are an integral part of this incredible story that is continually unfolding. So, what exactly are white holes? Are they real objects scattered throughout the universe? Or do they exist only as fascinating mathematical abstractions? To begin, picture a black hole, that well-known cosmic enigma that pulls in everything in its vicinity. Now, imagine its perfect opposite, a white hole, an object that, rather than consuming matter, violently ejects it. The very idea of such an object existing challenges our intuition. To grasp this concept more clearly, you can use the analogy of water in a river. A black hole acts like an impenetrable dam, halting the current and trapping everything behind it. In contrast, a white hole would be like a powerful spring at the river's source, gushing water outward and scattering everything in its path. This mental image provides a way to visualize how a white hole might operate, but it still leaves you with the fundamental question of whether they are physically real. Our current theories suggest a white hole could be the exit point connected to a black hole's entrance, a place where all the absorbed matter and energy might re-emerge. It suggests a kind of natural cycle. What goes into a black hole could, in theory, come out of a white hole. If this relationship exists, however, it begs the question of why you have never been able to observe one. One potential explanation is that white holes are exceptionally rare, or that they can only form under a very precise set of circumstances. While they are a valid mathematical solution to Einstein's equations of general relativity, that doesn't guarantee their manifestation in our physical reality. This leads to a fascinating speculation. Could white holes be phenomena that are confined to parallel universes, existing in dimensions that you have not yet learned to perceive? Imagine for a moment that somewhere, in a distant corner of reality, white holes are actively spewing out the raw materials that will eventually coalesce into new stars and galaxies. If that were the case, could these objects be the engines responsible for creating new worlds? Furthermore, you have to wonder what would occur if a white hole and a black hole were to collide. The meeting of these two contrary forces could produce phenomena beyond our imagination, perhaps even triggering the birth of an entirely new universe. Some scientists have also theorized that white holes could be the final stage in the life of a black hole, a kind of cosmic echo after it has evaporated. But you have to ask how such an idea fits into our current cosmological models. This is precisely where the study of cosmology becomes so crucial, as every new piece of evidence forces you to re-examine everything you thought you knew. The concept of a white hole also brings up deep questions regarding time and the principle of causality. If a black hole can effectively remove space and time from the universe, is it possible for a white hole to return them? This intriguing possibility makes you question whether time flows in only one direction, or if it is reversible. Could a white hole act as a gateway to the past, reintroducing matter and energy from events you believed were lost to history forever? This theoretical link between black and white holes also encourages you to consider the concept of entropy, which in physics is a fundamental measure of disorder. A black hole is associated with a relentless increase in entropy. A white hole, by expelling organized matter, might represent a decrease. The challenge is to reconcile these opposing principles, but perhaps across the vast expanse of the cosmos, entropy achieves a perfect balance through these endless cycles of cosmic creation and destruction. Let's move beyond theoretical curiosities and consider a more radical possibility. What if white holes are the very mechanism through which new universes spring into existence? It's a tantalizing thought that these mysterious objects could be functioning as miniature Big Bangs,
each one igniting a new cosmos from the remnants of an old one. In this framework, white holes might serve as the very origins of new realities, each governed by its own distinct physical laws and unfolding its own unique history. What would such a possibility mean for our own existence? If the universe you and I inhabit is merely one among a multitude, it suggests we could be surrounded by other realities, which might even contain alternate versions of ourselves. The very idea of parallel universes, where every choice you make spawns a new timeline, gains a fascinating new dimension when you factor in the potential existence of white holes.
Ultimately, this line of inquiry forces us to consider the very nature of human knowledge and whether we are genuinely prepared to grasp such profound phenomena. While science is progressing at an incredible pace, the number of questions always seems to outstrip the available answers. It is our innate curiosity that propels us to venture into the unknown, and perhaps one day we will uncover the evidence that finally connects the theoretical dots between black and white holes. In the end, white holes offer a captivating glimpse into the deepest mysteries of the cosmos. Even without definitive proof that they are real, the search for them inspires our continued exploration of the universe. It's possible that during our cosmic journey, we'll learn that white holes are far more than abstract theories. They could be the very key to deciphering the creation and ultimate fate of reality itself. So, the next time you gaze at the night sky, consider that every star and galaxy might hold a story, one that starts in a black hole and may find its conclusion in a white one. The arrow of time has long been a profound puzzle, captivating both scientists and philosophers for centuries. As you observe the world, time appears to flow inexorably in a single direction, from the past toward the future. But what is the reason for this? What fundamental principle dictates its forward march? To delve deeper into this phenomenon, it's incredibly insightful to examine the relationship between black holes and the passage of time. To begin, you can picture a black hole as a cosmic behemoth, an object with a gravitational force so immense that absolutely nothing, not even light itself, can break free. As you draw nearer to this giant, you would begin to notice a peculiar effect. Time itself would appear to decelerate. If you were holding a clock while approaching a black hole, its ticking would feel perfectly normal to you. Yet for a distant observer, your clock would seem to run progressively slower, a direct consequence of the way the black hole's gravity distorts the fabric of space-time. This raises a critical question about your fundamental understanding of time. If the gravity of a black hole can so profoundly alter its flow, might there be other regions in the universe where time behaves in entirely different ways? Could pockets of space exist where time moves backward, or perhaps not at all? This leads to the intriguing notion that black holes might function as gateways to other temporal dimensions. In a way, you could see a black hole as a kind of cosmic whirlwind that doesn't just pull an object into a zone of extreme gravity, but potentially transports it to a corner of the universe where the rules of time are radically different. Some theories even propose that upon crossing a black hole's event horizon, time could come to a complete standstill. This presents a fascinating thought experiment. If time ceases to exist inside a black hole, could any form of life or consciousness persist there? Is it possible that a sentient being could experience a state of eternity within the singularity, a point where time becomes a meaningless concept? The direction of time is also intimately connected to entropy, which is a measure of the disorder within a system. The second law of thermodynamics dictates that the entropy of any isolated system will always tend to increase, which gives time its forward-moving arrow toward a state of greater chaos. When a black hole consumes matter, it also takes in information. Yet the ultimate fate of this information and its connection to entropy remains a subject of fierce debate in contemporary physics. You could envision the universe as a vast kettle of simmering soup. As it cools, it becomes more orderly, but the flow of time points toward increasing disorder. In this analogy, black holes act like cosmic drains, where matter is mixed and transformed, but it's unclear what becomes of the information that falls inside. Is it completely obliterated, or is it preserved in some hidden form? A number of physicists propose that information isn't actually lost, but is instead encoded on the black hole's surface, the event horizon, leading to a new perspective where time might function more like a hologram, with each part containing the data of the whole. This link between black holes and the arrow of time also opens the door to speculation about the possibility of time travel. If a black hole can warp time so dramatically, could we one day harness these distortions to journey into the past or the future? While this idea has been thoroughly explored in science fiction, the practical and theoretical hurdles are truly monumental. You must also consider how time is perceived on different scales. While we experience it in a linear fashion, cosmic events near a black hole might unfold in a completely different manner. Returning to the arrow of time, it's compelling to think about the role black holes might play in the overarching cycle of the universe. Some scientists theorize that they could be the very seeds from which new universes sprout. In this vision, time might not be a straight line, but an eternal cycle, where the end of one universe marks the birth of the next. This intersection of cosmology and temporality leads us to the most profound questions of all. What is time? Is it a true physical dimension, or is it merely a construct of our consciousness? As we seek the answers, you realize that the quest to understand time is inseparable from the quest to understand your place in the vast fabric of the cosmos. Even with so much still unknown, every finding brings us nearer to comprehending the essence of time and its function throughout cosmic history. Time, therefore, presses onward, pulling us in its current toward what lies ahead as we continue to probe the mysteries the universe holds. Modern cosmology navigates deep and frequently chaotic waters, much like a great vessel on an ocean of theories and breakthroughs. Yet, throughout this voyage, controversies and critical viewpoints surface, questioning our most deeply held convictions about the cosmos. A significant source of these challenging inquiries stems from observations made with the James Webb Space Telescope. Is it genuinely reshaping our grasp of the universe, or are there facets of its findings that we have failed to properly analyze? While some contend that the clarity of the images and the quality of the data from this telescope are extraordinary, doubts are also emerging. Are you certain we are interpreting what we are seeing accurately? At times, what seems to be a faraway star could prove to be a completely different cosmic event, prompting a crucial reflection. Could our own expectations be preventing us from seeing fresh possibilities? Take, for instance, the rotation of galaxies, a riddle that has baffled astronomers for decades. With 2/3 of all galaxies spinning in the same direction, a question persists. Are you observing a genuine cosmic pattern, or is it merely a result of cosmic chance? This observation could signal that our fundamental theories on gravity and dark matter require a thorough re-evaluation. Critics propose that our desire to make data conform to existing models might be causing us to overlook vital aspects of the natural world. The conversation becomes even more intricate when we turn to the subject of black holes. Is it possible that the existence of these massive objects fundamentally alters how we perceive the universe's structure? Some researchers propose that the James Webb Space Telescope has uncovered nascent black holes in their earliest formation, a discovery that could transform our views on galactic evolution. This leads to another question. Have we been searching in the wrong place all this time? Similar debates surround cosmic inflation, a theory designed to account for the universe's uniformity, which some critics feel lacks definitive observational proof, forcing us to ask if we can rely on a model that remains unverified. This climate of uncertainty provides the ideal conditions for discussion and skepticism, which are the very bedrock of scientific progress. These disputes are not confined to theories about the universe's origins. They extend to how we interpret the data itself. Faced with a continuous deluge of information from the James Webb Space Telescope, you have to wonder if we are filtering this data through our own biased perspectives. Some researchers fear that we are trapped by outdated paradigms, which stop us from seeing the cosmos as it truly is. Consequently, certain astronomers are now questioning if we are truly prepared to accept the ramifications of these new discoveries. Do we possess the courage to challenge our most enduring assumptions and adopt a completely new framework for understanding the universe? The quest for knowledge is a continuous process, and every new piece of the puzzle urges you to reassess everything you thought you understood. It's possible that black holes operate in ways we've never conceived. If you consider that each black hole might be a universe in itself, what does that imply about our own place in reality? Such questions push against the limits of our scientific models and force us to contemplate our position in the grand cosmic scheme. This connects to the Fermi paradox, which asks why, despite countless new discoveries, we haven't detected any sign of advanced alien civilizations. Are we simply not looking in the right places? Maybe intelligent life has developed methods to remain hidden, tucked away in the shadows of black holes or in unexplored corners of space. What's truly inspiring about these debates is how they compel us to approach problems with greater creativity. The concept of white holes, the theoretical counterparts to black holes, presents fascinating possibilities. Could these be gateways to escaping the confines of our universe, or are they just interesting mathematical abstractions? Speculation of this nature requires you to question the very limits of our knowledge and the fundamental properties of space itself. There is a critique that the scientific community has grown overly dependent on established models, a reliance that could be restricting our ability to identify new phenomena. In this light, the James Webb Space Telescope serves not just as an instrument of observation, but as a mirror showing us our own intellectual constraints. Are you willing to push past these boundaries to truly expand your comprehension of the cosmos? As you navigate the complex currents of modern cosmology, it is vital to remember that science progresses through criticism and intense questioning. These controversies are not impediments. They are chances for development and for broadening our perspective on the universe. Therefore, when presented with new evidence, you must ask yourself if you are truly ready to release old certainties and welcome the unknown. Ultimately, the inquiries that arise from these critical observations often carry more weight than the answers they might yield. What is the true meaning of being a part of this universe? Are you prepared to concede that our current theories might only be the first stage in a far more extensive and elaborate journey? The solutions may not come quickly, but it is the persistence in asking these questions that will guide us toward new frontiers in our cosmic understanding. The chronicle of cosmology is filled with unexpected twists and astonishing revelations, with each new breakthrough moving us further from our previous certainties. In the end, the true magnificence of science is found not just in its power to resolve questions, but in its capacity to unlock new ones that drive us to look far beyond the immediately apparent. The sheer scale and wonder of the universe frequently leave us in awe. You are faced with some of the most profound and intricate questions imaginable. What is your genuine position in this immense cosmos? Are you truly alone? Or could there be advanced societies observing you from across the stars? Our inquiry has delved into captivating topics that point toward a singular conclusion. The theory of black hole cosmology doesn't just reshape your perception of the universe. It unveils a spectrum of possibilities straight out of science fiction. The very concept that our universe could be a black hole compels you to reevaluate everything you consider to be real. If each black hole in our cosmos serves as an entrance to a new universe, are you simply residing in a cosmic bubble that is itself a fragment of something far more immense? This idea forces a radical reconsideration of your ideas about space and time, initiating a profound conversation about the essence of existence itself. Investigating black holes and their ties to the universe's architecture prompts you to contemplate the fundamental forces that shape your reality. Gravity, which you typically experience as the simple force pulling you toward the ground, is revealed as the central character in the cosmic drama. This raises critical questions about the forces driving black hole formation and, more importantly, what this means for your comprehension of time and the universe's history. The James Webb Space Telescope has provided groundbreaking insights into these very questions. Its observations have enabled scientists to gaze deeper into space than ever before, uncovering vital clues regarding the development of galaxies and the black holes they contain. The secrets embedded in these cosmic images suggest that an enormous amount is still left to be discovered, and that black holes might be the very key to solving the puzzle of life in the cosmos. Let's turn our attention to the rotation of galaxies, where a perplexing pattern emerges. The fact that 2/3 of observed galaxies spin in a particular direction directly challenges the assumption that the cosmos is random. This discovery not only casts doubt on current theories, but also makes you wonder if there's a deeper, more fundamental order that has so far gone unnoticed, with the answers possibly concealed within the structure of black holes themselves. The prospect of nested universes, with one existing inside another like a set of Russian Matryoshka dolls, is an equally captivating idea. This framework makes you question just how many separate realities could coexist at the same time. If your universe is but one of many layers, what might exist in the others? Could they be home to forms of life so different they would defy your very imagination? When you consider the singularity and the event horizon of a black hole, a striking parallel can be drawn to our own cosmic situation. What if the boundary of your observable universe is, in effect, its own event horizon? This startling concept prompts you to reflect on the inherent limitations of human knowledge and the vast mysteries that lie beyond your current reach, suggesting you might be enclosed within your own cosmic boundary. The mind-bending notion that every single black hole could contain its own concealed universe is staggering to contemplate. It begs the question of what sort of life could possibly thrive inside these enigmatic phenomena. The idea of each black hole acting as a cradle for new universes forces you to ponder the very nature of creation, speculating whether these hidden realms might be alternative versions of your own reality. As you delve into the mechanics of gravitational collapse and the birth of black holes, it becomes evident that the cosmic cycles of life and death are inextricably connected. The collapse of stars into black holes represents a perpetual process of destruction and rebirth. This celestial rhythm invites you to ask what you can learn about your own existence from this grand cycle, and what the purpose of life is in a universe governed by it. A compelling theory suggests the possibility of a bounce inside black holes, a mechanism that would prevent the formation of a singularity and allow existence to continue in a new form.
This concept encourages you to see time and space as far more flexible than you previously thought. If you connect this to cosmic inflation and view the Big Bang as the result of such a bounce, the consequences for your understanding of cosmic history are immense, portraying the universe's expansion as part of a much larger cycle of transformation. Theoretical frameworks involving Einstein-Rosen bridges and wormholes provide a glimpse into a universe that is deeply interconnected. These hypothetical cosmic tunnels could potentially offer passage between vastly different realities. The sheer possibility that such hidden pathways exist strongly suggests that your current understanding of space and time is merely scratching the surface of a much more complex and interwoven reality.
Finally, contemplating advanced civilizations and their potential mastery over black holes makes you reflect on your own trajectory. Is it conceivable that in the boundless expanse of the cosmos, other life forms have learned to create or manipulate black holes? In this context, the Fermi paradox, which asks why you have yet to find any evidence of such civilizations, becomes especially poignant, hinting that the answer might require a complete shift in how you view the universe. The persistent enigma of the universe's fine-tuning, the observation that its physical constants seem perfectly adjusted to support life, remains a profound mystery. This leads to the speculative but fascinating possibility that our universe is an artificial black hole, a thought that challenges your perception of creation and the role you might play in the cosmic story. The enduring mysteries of white holes and the arrow of time ensure that modern cosmology remains a field of vigorous debate, leaving you to wonder if you are on the right track or just beginning to grasp something much deeper. As our journey into the cosmic unknown progresses, keep in mind that each discovery serves as a launchpad to a more profound comprehension of our role within this immense universe. We can only wonder what other enigmas the future has in store for us, as this grand exploration has only just begun.